Hey guys, we're live. It's Saturday night, 7 o'clock here in California. I'm at the dyno as usual, dyno testing. Hello, everybody who's just tuning in. That's awesome. Tonight, we're going to talk about, obviously, I'm doing more testing on the 4.3 liter, the little L99. Last night, I was able to do some stuff. And today, we did a couple of different size headers. We did some ported aluminum heads. And right now, and we'll go in there and I'll show you where I'm in the process of putting a different camshaft in, which this thing has desperately needed. The camshaft that we had in there before was not great. As a matter of fact, I'll tell you what the specs are on that. So we had a 410, 427 lift split, which is fine. A 207, 214 degree duration split. It's a little mild cam, but it had a 117 degree lobe separation angle, which is really, really wide. And what that does is a lot of guys will use that for positive displacement blower cams. What that normally does is kind of kill most of the power in the bottom and in the middle portion of the curve. In fact, it did when we compared this to the other smaller cam that we had in here before when I ran the test way back. It basically killed power all the way up to the top of the RPM range. So the really, really wide LSA is not a good idea on this combination. Here we go. John's in for $5. Aaron's here. Patrick's here from Georgia. Yeah, the peach, Georgia peach. This is not a good cam. The cam that's going in, and I'll go ahead and I'll get the specs on that, but it's much bigger. And we're finally getting up into what you might consider like a performance cam, although ain't really any camshaft is a step up from a lot of the factory stuff as we've seen before. But this last cam that we put in here with this 117 LSA was just not a good choice. It just happened to be what we have available, so we want to try different things because a lot of times when we try stuff and it doesn't work, that's also good information. I mean, we always want to be hero and put something in there, and it's always going to be, make big power, but that doesn't always happen. We find stuff that doesn't work. I know when I was doing Engine Masters, I found lots and lots of stuff that didn't work. As a matter of fact, I found way more things that didn't work. And when I say didn't work, I don't mean that they didn't add power. I just mean that they didn't improve our average numbers. They may have picked up at the top and lost at the bottom, but the average numbers stayed the same, which was very, very common. It was hard to get gains everywhere after you get to a certain point, and then it's hard to get more of a gain somewhere to offset the other loss somewhere else. So that was a lot of fun doing that stuff and finding out what works and what doesn't. And it just, for me, it took a lot of testing to figure out what a really good combination was, and all that hard work paid off. And then they did what they did to the motor, so it didn't work out very well for me, but it was still cool. So I want to thank all you guys for showing up. Thank you guys again. It's Saturday night, 7 o'clock. We're having fun. We'll go in. As a matter of fact, we'll take a walk in there and I'll show you guys what's going on with the motor right now. It's basically right in the middle of a cam swap. I just got done pulling the other smaller camshaft out and I'm putting the bigger camshaft in. And it has now been put in, but I'm right at about the point where I've got to adjust the rockers and then put the intake manifold on, and then I can start making some runs. And then the tuning part of it is very, very fast. I mean, we have the Holly hooked up. We have a program for it. Because I've been tuning this thing for a long time, we know what it does. It's very easy to add and subtract fuel and add and subtract timing. Although so far in the changes that we've made, timing changes haven't really shown very much. So it's like the same timing for all of these combinations. Right now, it is flat at 30 degrees all the way through from 2,500 all the way up to 6,000 RPM. And it doesn't seem to want any more than that, but it also doesn't seem to want less than that. So it tells us what it wants and we give it that. We got to listen. Julius, yeah, Australia, what's up? Baghdad, nice. 80 degrees here in Florida. Yeah, it was pretty warm today in California. I actually got to go to the wrecking yard today. I had to pick up something for a project that I was doing. I had to pick up another plenum for the tune port because I may do something cool with two of them later on, but we'll see how all of that works out. But I had to go over to the wrecking yard, and I even stayed away from all of the other stuff. I didn't take another walkthrough and look at all the other cool stuff. The one thing that I did go look at is there was a motorhome there with a 440, which I really want. But after taking a look at it, I don't think it's good. The problem is there's a lot of stuff that's missing. People have gone in there and stripped some of the stuff off. They had taken the intake manifold off, which wasn't too big of a deal, but I actually found the intake. The intake they took off and just cast it aside. So I was able to find the intake manifold. But they also took the valve covers and the rocker assemblies and the push rods and stuff. And so I don't want to have to source that stuff. I would like to get a 440 that's all complete, so I have all the things. Even if I'm going to replace them, it just makes it easier than having to piecemeal things together just to get it to run on the dyno, because that's the first thing that we'd like to do, obviously, is find out, get that thing from the wrecking yard and hook it up with a distributor and carburetor and stuff if it doesn't have that stuff already, and then make it run and see if it's a runner, because that's what that's like my pride and joy is going over to the wrecking yard and finding a motor that needs another home or it needs attention and putting it up on the dyno and starting it up for the first time and having it you know, have it fire up and roar to life, and we get to see oil pressure and all of that stuff is good. And it's just awesome that you can go get a used motor like that and put it up on the dyno and have it work. And not only have it work, but a lot of these times they work very, very well. I mean, look at this thing. This thing came from the wrecking yard, and this thing has, I don't know, it's got a few hundred runs on it now, so it just keeps going and going, and hopefully it will keep going so that we'll be able to do more and more testing with it. But let's take a walk in there. I'll show you what the other camshaft is that just went in, and then kind of show you where we are on our process here of this L99. So here are the cam specs from the other TPIS cam. Let's see if you guys can you guys read that? Let's see. There we go. Come on, focus in. Basically 220 at 50. It's a low lift. It's their super L98 cam, 112 degree lobe separation angle. 450 lift, so it's a fairly mild one. Although I do have 1.6 rockers and not 1.5 rockers, so that's the lift with 1.5 rockers. You can see here is the here's the mess, and here's all the stuff that's going on. But this is the engine, and as you can see, the thing that's different from guys that were here last night is it has now aluminum heads on it. It no longer has these iron heads, because we replaced them with a set of ported Lt1 heads. Now the Lt1 heads have bigger chambers on them than these do, and I'm doing a video on that, so I will tell you exactly what the chambers were on both of these heads. But it has bigger chambers, but it has been ported. It also has a valve upgrade. It has a 2-inch valve and a 155. It has obviously different valve springs on it. There is chamber work done. There is port work done. So I will need to flow these to tell you guys what the flow rates are. But we are, and then we're in the process of putting the camshaft in it. I've got the tune port stuff over here. We're going to run it again with the tune port stuff. And then I'm going to put a carburetor on it, because honestly, here's the tune port manifold. Because obviously the tune port stuff was cool, but I don't think a lot of guys are going to do that. And ultimately, the tune port stuff is limiting to other modifications that you make, because it wants to run in a given RPM range. So it's not, you're not able to take advantage of what, you know, a good camshaft or ported heads or those kinds of things might have to offer if you limit it with that induction system. So we'll try a few different induction systems on it so I can illustrate that and show you what's going on, and we'll see what it all does. We'll see what kind of power it does. But you can see I'm just getting ready to I've got to adjust the valves. I've got my Allen wrench. Got to get my 5/8. Get my 5/8 and loop it on there so that they're there ready to go. So then I just turn the motor over, and I like to go in order. I don't like to go in the firing order. I like to go this one and this one and this one, this one, this one, and I just rotate it around until I get into the position that I want. Basically, you just need it on the heel of the cam, and I put about a half turn in it, and that seems to work really well. We'll find out how high we can rev this thing. We may have to look into a valve spring upgrade, but we'll see what happens. I don't know how, with the tune port stuff, it's not revving very high. We're going to 6,000, but it's making peak power way before that. The other thing that happened, as you can see, these are the 1 5/8 headers, and these were the 1 3/4 headers. So not only did we have a difference in primary diameter of the runner, But we also had there are slightly different lengths because the engine 5/8 headers are not equal length because they're inexpensive. They're some kind of inexpensive chassis header. So, and then they also have different collectors. So one of them has a 3-inch collector. The engine 5/8 has a 3-inch collector. The engine 3/4 has a 3.5-inch collector. And the collectors are different lengths. So you got all kinds of things that have changed on this header test. And again, it's not because I wanted to do an exact back-to-back test of specific headers. These are just headers that we happen to have, so I can get a broad idea on what happens when we go from a bigger header to a smaller header. So let me ask you guys, and I'm going to do this in the video too when I finish editing it. What do you guys think the power difference will be going from the engine 3/4 header to the engine 5/8 header? Does this combination want the smaller header? Does it make more down low? Does it make less up top? What do you guys think it does? Be interested to hear some of the comments and find out what you guys think that the power difference is going to be, if any. Sometimes we put headers on and it does nothing. So and we see big changes in the design of the headers and then see nothing in terms of power. I've done that a few times on LS motors where we've run what I think are dramatic changes in header design, and we just didn't see any power difference. So let me know what you guys think on that stuff, and then we can get to some questions, although I promised you guys a sneak peek of what's going on. So let's see if anybody has the 2-inch 155 do fit the bore. I did a video on that before where I put not only the Lt1 head but also the Lt4 head on the bore and basically actuated the valves, and both of them fit. Now I didn't measure it to know by how much they fit, but both of them do fit. Okay, Patrick, have you ever run Rock Performer RPM cam, lifters, intake, and carb on a small block Chevy? No, but I don't think I've done that small block. We have done a big block, and I have done a Ford, and I've 351. And every time that we've run it, it does what they say it does, because they're actually very good about dyno testing their stuff. So if they tell you it adds this much power, it does, because they've done a lot of testing. They have dynos, and they're not going to advertise something that it makes this amount of power, because they would obviously get in a lot of trouble if it doesn't do that. So they're pretty good about that. And if anything, like with the 351, they were a little conservative on their stuff. We made a little bit more power than that. See, Tom doesn't think there'll be a big change. Karen says the smaller header might make more average power. It would be good to, Ron says it would be good to see a modified crossfire manifold with carbs on top. Yeah, I agree. I remember seeing Freiberger tested a few of the early cross rams, like the DZ302 stuff, and it actually worked out pretty well. He was very surprised, but it does look cool. But it would be nice to, that's one of the things I was thinking about if I got the throttle body version, the L83 Crossfire, is I wondered if you could make another lid for it and put carburetors on it, or even if you could put two 500 CFM 2 barrels on it, that you might still have enough. That should be enough flow, I would think, to feed any sort of crossfire combination that you'd put together. Where is your outfit located? L99 and push everything to top end. Let's see. Joyce is saying there's no difference in power, header size, as the flow still is not limited by that volumetric efficiency of that motor. How safe is a 100 to 150? I'm thinking you're saying how safe is a 100 to 150 shot? It's fine. It works good. Renegade Performance makes a great crossfire manifold. Art wants to know, when putting in putting gaskets, do you use gasket maker or just the gasket? I've been reusing these gaskets. I reuse the head gaskets, and I've been reusing the intake gaskets, you know, 5 or 6 times now. The guys from TPIS sent me a set of intake gaskets, but I haven't used the new ones because the factory ones are in really good shape, so we just keep using them. We know those inch and 3/4 headers are ringers, or you wouldn't have used those. Actually, the reason that we have those inch and 3/4 headers, they're kind of like a sprint car header. The reason that we have them is because we have access to everything. It's really easy to put them on. It's easy to put the bolts on. They're not in the way of anything. We can run the wires underneath. There's plug access, and we don't have to worry, because that's one of the problems with these chassis headers, the inch and 5/8, is plug access and plug wire positioning is critical with those, and sometimes that happens when you have to make the header fit in a particular chassis, which those those dyno headers don't fit in anything other than, you know, an open sprint car, which is kind of where they get their name from. If I did heads cam and TPI swap on a 305, could I increase horsepower, torque, and fuel mileage? Yes, if you use a small cam, but the fuel mileage thing is more about how you drive it. Yeah, Tim, there weren't any LS1s with Gen 4 rods. Kenneth wants to know, do you oversize injectors when you run boost? Yes, I have a video up on how to calculate that. But I always leave myself plenty of room, because if you run boost, you're probably going to try to run more boost. So you want to have, and it's so easy to add power with boost that you want to give yourself plenty of leeway. And the other thing is, we give ourselves plenty of leeway, because if you calculate it based on fuel, what happens if you want to run E85? Then you'll need a much bigger injector. So we might as well put a big one in to begin with. Like I have a set of 1500s in there, which are enough for a pretty good power range. What is the effect? What is it? Hydry Wizard? What is the effect of intake runner length versus displacement on the TPI motors? Does it affect more of an effect on the L99 than on a 350? You would think that there would be, and I expected there to be. But looking at the data I have from this L99 and a 305 and a 350 and even a 383, the tune port stuff seems to make the power at about the same RPM. That's not terribly surprising, considering the fact that the runner length is a reflected wave and it doesn't care about the displacement. The runner length, the reflected wave for the runner length is just the length of the runner, because the reflected wave has to travel up and back the length of the runner. It travels at the speed of sound, so the distance is the same, the speed is the same, and so it arrives at the same time to optimize cylinder filling in terms of the reflected wave. The other things that happen that are also part of it, Helmholtz resonance and inertial ram, are different though, and the Helmholtz resonance is affected by displacement, and so is the inertial ram. So, but like I said, when we did this, that's why I put the tune port on there. I expected the tune port on the 4.3 liter to make power at a higher engine speed than the 305 and the 350, and as it turned out, it's not doing that. Aaron wants to know, what's the best injector to run in a factory 5.3 to best gain? You don't get gains from an injector. You get gains from the boost. You just have to have enough injector to feed the fuel for the power output that you want. So if you want to make 500 horsepower, you need injectors that will support 500 horsepower or 600 or 700. It's always, like I said, it's always better to go bigger than that. There is no best injector that's going to add extra power. If they give you the right air fuel, 11.5 to 1, then they'll make the power that you want. Let's see. Yeah, and Steve, we're not just talking about the L99 isn't the only thing we're talking about. Obviously, there's lots of questions and other stuff. And I do want to get, I'm getting a 440, looking for a 340, and I'm definitely also going to do a Magnum. So I got lots of Mopar stuff coming. Adrian wants to know, what about pound for pound effect of collector diameter? So I don't know what the pound for pound thing is, or if that's just a euphemism, but you want to find out what the change in collector diameter does. That's a little bit harder test because the way that they merge those together into the collector is a difficult thing to change. We have changed, I have done tests on collector length, and the length of the collector definitely has an effect on the power curve, especially down low. Tom wants to know if we've unlocked all of the secrets of the internal combustion engine. Obviously not, because people keep making more and more power every year. Richard, would you do an L83 crossfire test? I do want to do that. I would like to do an L83. Jesse says, I'm running a 469 comp cam in my 2001 Firebird. What size stall? I'm not a transmission guy, but I think that thing is going to be something like a 2800 or something, 2800 or 3000 stall probably. Karen says 3600. The 273 to 360 small Mopars all have the same deck height. So then if that was the case, then why can't somebody make a 340 out of a 360 block? Because the 340 is just a bigger bore. Joseph wants to know if I'm going to be doing my own cams. I have a whole bunch of them, and I probably coming up will be getting rid of all of them. So there'll be good deals for you guys to get rid of all of the development cams that I have, but they're not. I'm not ready to do that yet. Richard, how much parasitic loss does the ProCharger crank drive have? It's not that drive itself. It's actually the blower that has the parasitic loss. There may be a change in loss from that big crank-driven deal, but that loss is not going to be anywhere near what it is from the blower. The blower has a lot because it processes a lot of air, and that takes a lot of power to process that amount of air. And blowers, whether they're a ProCharger or a roots blower or a twin screw or whatever it is, all require power to do that. And the higher the flow rate, the more power it takes to drive that, and so the more parasitic loss. But the plus side, obviously, is that if you have a 300 or a 3,000 horsepower ProCharger and it takes power to drive it, the net gain is pretty big. What is your favorite power adder for a street car that sees the drag strip a few times a year? I drove for years and years and years with a Vortex supercharger on my Mustang, and I loved it. But having driven turbo stuff now, I also love that. I loved my little Sprint turbo. You know, anything that I've had with any kind of power adder, they're all good. There's not one that's absolutely better than others. Otherwise, then there would only be one that exists, and all the others would go away if there was one that is universally better. So there's lots of good stuff. For a truck, having a positive displacement blower, I think, would be really, really good. unless you have a 4060 trans, then maybe not. Turbo stuff obviously is always good for anything. And then, like I said, I loved having the Vortec on my Mustang. A homemade ram air kit for a Mustang GT in the fog light hole made 1 mile an hour and 1/10. That's not surprising. And it's, you know, I remember back in the day, people arguing about that is what is ram air? Oh, we're building positive pressure in there. It's actually not usually that. Unless you're going really, really fast, you're not building positive pressure in there. It's just that you're getting cold air. And that's what you need to do. You need to get outside engine compartment ambient air. And if you can get positive pressure, that's even more of a benefit. I haven't seen, Kenneth wants to know if I've seen a mag Whipple for a Gen 1 small block. Whipple might make one because Whipple makes a replacement for 671s. So I think that probably, if you have a 671 for a small block with that manifold and you have a replacement Whipple for it, that probably would work. Low down, cheap and dirty. You have a Gen 6 big block with Edelbrock performer heads, stock pistons. What cam should I use? You're kind of limited in the cams you can use, like that 274, 276 cam that I've run a few times. I think we might have put a 282 in there also, but all that's getting really close. You're definitely going to need springs with those cams. Can you test gains from rotating mass on the dyno, or is the rate of RPM increase too slow? No, we actually did do that. I did a test where we ran, one of the things that we can do that's very quick and easy is the way that we attach the motor to the dyno is a flywheel. The flywheel is bolted onto the crank, and then we have a drive plate, which looks kind of like a clutch, but we have the drive plate as a center hub like a clutch, and it's splined, and that's what the input shaft goes in there for the dyno, and that's how it drives. That's how the motor drives the dyno. Well, we have steel and aluminum flywheels and drive plates. So we can change those two things and make a pretty significant change in the rotational weight. And there is a change in power when we do that. So that we know that also if you did it in your rotating assembly, although it's a lot closer to the center line when you do your crank, but if you did, you know, changes in your piston weight, which is all the way out on the end, or the rod weight, all of that stuff should help, and it should help make power. And this is on a controlled rate of acceleration. You might see something even more on a chassis dyno or even on the street. Luke's Autotech, what kind of valve lash do you like to run, and does being tighter or looser affect the power? It does. We obviously on a hydraulic roller like this, I just put a half turn in it. That's just preload on the lifter, so there's no lash. But on a cam that requires lash, a solid flat tappet or a solid roller cam, you can play with the lash. But it has a lot to do with the ramp rate of the cam. But generally, if you tighten the lash up, you effectively make the cam bigger. So what can happen is you can lose power down low and gain power up at the top. And a lot of times we'll do that to play with it, but you have to be careful about the amount of lash that you run. Some cams are ground specifically, and they're known as tight lash cams, and you can run very tight lash, a few thousandths, which makes it almost like a hydraulic roller with zero lash. And you can adjust power by changing the lash. It also changes the noise quite a bit. I remember specifically on the Duntov 3030 cam that I ran on some of these legendary small blocks, it really likes tightening the lash up. Having 30 thousandths lash was the thing ran terrible. I know, what's up with the math, huh, Tim? 163 are watching, only 63 likes. So you guys that are watching that haven't pushed a simple like button. So what's up with that? So you come here and get all the free information. I get no likes. I get no love. I get nothing. Man, come on. Let's see. Michael Underwood, how much horsepower are you leaving out a knock sensor telling you if you're getting close to maximum horsepower? We're not leaving any out on our testing because we keep adding timing until it stops making power. So we know that we don't have knock sensors on this. So we're going by what the dyno says. So we keep adding timing until it's not making any more power. When it doesn't make any more power, there isn't any more power to be had. So the knock isn't like pulling countermeasures against us to do that. And the same thing with air fuel. We will start out rich normally, and then we will lean it out until it stops making power. This tune port motor, for instance, we ran from 11-to-1 all the way to 13-to-1, and there actually wasn't a big change in power. It was not terribly sensitive to air fuel. It was a little bit more sensitive to timing, which is usually the case when we do this tuning. Here's a question. Can you use a radical cam and compression ratio single plane on a 4x4? Yeah, but I don't think you'll be happy with it because it just makes the thing peaky, and you have a very short or a narrow RPM range normally. Usually 4x4 is like a broader power range. See, that's what we like to hear, Patrick. I always like and share. You got to do both. That's one thing I want to, and I'll do this in the videos too. Make sure that you guys go share with people and let them know about the channel, because there's probably a lot of guys out there that would like information and that are not getting it. So if you guys have any buddies out there, make sure to share it with them. I have the Cam Motion low lash cam. I run 10 thousandths cold lash, solid roller, LS headed 427. See, that's like a real motor. It's like a serious one. Edward Clark. I have a quick question. The difference between a 5.7 old school versus an LS1, then LS2 6-liter versus truck 6-liter, and the Denali 6.2 versus a Camaro 6.2. See, that's not a quick question. That's a lot of questions. And there's a lot of different answers for that. There's a big difference between all of those. Well, some of them there's not a big difference. Some of them there's just a difference. But the LS2, you can look up all the specs on the internet and see what the difference is between the truck motor. There's compression, there's intake manifold, there's cam timing, there's several differences. And between a 5.7 old school one like an L31 and an LS1, there's a lot of difference between them. There's a difference in power. There's a whole different engine family. The cylinder head's different. It has a windage tray, which nobody ever talks about, which is a good thing on the LS motors. The intake manifold is much better on the LS engine family. There's a lot of good stuff. Yeah, Mike, you're right. Mike was saying that he had the same experience with the Duntov cam on a 327, and that's what I ran it on. We ran it on a 327 and on the 302, and 30 thousandths was a lot. It was noisy, and it just didn't seem very happy, and it really liked when we tightened it up. And I think that's about where we went to was 10 to 12. We just kept tightening it up, and it just kept getting happier and happier. No red solo tonight. Well, not that you can see. I did gaming. What do you do with the motors that you build? I run them on the dyno and test them. I have a whole bunch of them. Woody 74 Nova. Hey Richard, LQ4 2500 HD. I have a 799 heads that are being ported. Basically everything else is stock. Which cam would you recommend? I'm still using it as a truck. And which injector size? The injector size can stay stock because you're not going to be adding that much power from porting the head. You can, if you wanted more torque, well, you're putting 799 heads on, so that's a good head. That's going to be a good upgrade on that, especially if you port it and you could mill it, which would be good also. And then if you put a stage 1 or stage 2 truck cam in there, it would be good. Is it necessary to have my car tuned with a 100 horsepower wet shot through a plate kit on an LS6? No, you don't have to have it retuned on that. You can have it tuned when you run the nitrous if you want to run it on the dyno and find out if your the fueling for the nitrous is working out, because sometimes, a lot of times, the nitrous companies will recommend their kit, their jetting is very safe on the fuel side. And then also, depending on what your fuel supply is to your nitrous, what the pressure is, you need to figure out, that's really the thing with the nitrous, is figure out if you're getting too much fuel along with your nitrous or not enough, which would be bad also, and then figure out how much timing you're going to pull. We normally do, on a 100 shot, sometimes we don't pull any timing, but sometimes 2 or 3, depending on what, and then we adjust that based on what kind of octane we have. If we're just doing 91, we'll be safe. We might pull 4 degrees. It doesn't seem to make a big difference on the nitrous. But if we have good gas in it, we don't, on a 100 shot, we won't pull any timing. And I ran lots and lots in my Mustang back in the day, in my 5-liter Mustang on 91, and we never pulled any timing on it. Edward wants me to make some merch. We're going to do some shirts, I think. How much horsepower do I get per sticker? Well, that's why we have to limit the stickers, because you end up getting too much power. Stefan, do you know any good dyno tuners in Colorado? Yeah, Brent from PF5 is the one to go to. Oh, did he go? Did he move to? Somebody's saying that he moved to Florida. Edward saying, I think he did a test on heads and the 706 came out on top. It depends on what your application is. On a 5.3, the 706 makes the most power. On a 6-liter, a 799 actually made more peak power. It lost a little bit down low compared to a 706, but it's still a good head. And if you were wanting to make, if you had a cam 6-liter where you're wanting to make 500 or 550 horsepower, then the 799 would be a better head, because you have a combination that now can take advantage of the extra airflow offered by the 799. It's not a lot, but it is some. And if you have a motor that will take advantage of that, then you want to use that head, because the 706 will ultimately become restrictive on that combination. Okay, they said the shop is still in Colorado. I thought that it was. Oh, Boosted Boys went to Florida. Robert wants to know, 4.8-liter LS, best cam for a daily driver. The little torque cam, and other guys have them too. I'm sure Texas Speed and Cam Motion, those guys have them. But I've tested the torque cam from Brian Tooley. That one's pretty good for a 4.8-liter. A lot of guys tend to over cam 4.8 liters, and I've talked about that before. You don't need a lot of camshaft in that motor to make a lot of power with it, especially with the turbo. Jason Wilson, what's your favorite motor? Whatever the next one is. The LT5 was more of an experimental motor, John. We have an LT, well, I say we. Westech has an LT5 motor here, and I'm trying to get them to run it. Mike wants to know, would 10.5 to 1 compression be too much for E85 with a turbo? No, because factory LS stuff is that high. So we've run that, and especially with the E85, it will work good. Sinister Silverado. I have a 4.8 with a Summit 8719. I don't know what, I don't know the Summit designations off the top of my head. You'd have to tell me what the duration is at 50. SM Turbo 4.8 liter single GT35, 10 psi, blow through carb on pump gas, be okay with no intercooler. Yeah, the 10 psi is getting up there, and that GT35 is not going to support very much power on a 4.8. A GT45 might be a little bit better. It settled. We want the wrong cam shirt. That's the one that we're going to make. Let's talk quench, NA versus turbo. They both need to have quench. Jeffrey, Richard, when you do the 3800 stuff, I'd be interested to see some Aussie Commodore intakes because since they were set up for rear-wheel drive. I don't think I've seen one of those. I was looking at a lot of, whenever I go to the wrecking yard, I look at all of the intake manifolds on the 3800s because there's a lot of them. I'd actually like to count them sometime and see how many different ones there are. But there's lots of composite ones. There's the NA ones, obviously the boosted ones. And then there's the stuff on the F-body stuff as well. Woody's, hey Richard, back to the truck. Are you talking about a Brian Tooley cam? Stage 2 truck cam would work on a 6-liter if that's the same one that we were talking about. The torque cam is a small one for a 4.8. Is there any way to do testing on a North Star? There's a whole bunch of them at the wrecking yard, or at least there were last time I was there. But I've never run one other than on the chassis dyno. Maverick wants to know quench numbers, 30 or 50 quench are. I don't think I think if you did any testing with quench, you might see some change in its susceptibility to detonation. I don't think you'd see anything in power, especially in that range, in the 30 to 50 range. I think if you go way out of that range, like we've seen, like the 440, for instance, some of those pistons are 100,000s or more down in the hole, so they have no quench. And some of the Ford 460 stuff, I think, is like that as well. But the quench is going to kind of be determined by the gasket thickness, unless you bring the piston out of the hole, which not a lot of people do. I think that some of the LS stuff might have been like that. I think we've measured some of those that were out 6 or 7 thousandths out of the hole, and then they're taking up some of that gasket thickness. And then you can obviously adjust the gasket thickness to do that. But I honestly don't think you'd see anything in that range. Oh, Julius, okay, thanks. If I want any Aussie parts. Julius, if you have any pictures of the intake manifold, send me some pictures. Woody 74 Nova. I like to keep my quench at 20. So how much piston to head clearance do you have at 20? Luke's Autotech. Can you hook up a J series Honda to the dyno? I am going to run one, either a J32 or a 35. We're going to make an adapter for it. Here I'm getting other quench questions. Here's the thing I want you to think about whenever I look at anything. So when you look at something like quench, what is the big thing that you're changing there besides quench when you're testing that? That's compression. So if you see a change, are you seeing it because of compression, or you're seeing the change because of quench? Rob wants to know my thoughts on a 231, 236, 629, 615, 115 on a turbo 5.3. Well, you know what I'm going to say, that every cam is a turbo cam. You don't need a cam nearly that big on a 5.3 unless you're looking for a whole lot of power. Somebody's asking if I saw Alan Milliards. I'm not familiar with them, so I haven't seen their new video or any of the old ones either. A Big Bang Honda J Series. I like the J Series motors. I always have. We've run quite a few of those here, or at least Eric and Ish have on the chassis. Lots of them in sand rails and stuff. And that's a good motor. A buddy of mine, Jimmy from HP Performance, that used to run HP Performance, has one that he's swapping into his NSX, a 3.2 liter. So it's a big stroker motor for the NSX. So that will kind of be cool. And I like those motors. They're in all of the sand rails and stuff. Everybody had turbos on them. They work pretty well. Random wants to know what was the max time in the Big Bang 351. Honestly, don't remember. I'd have to look up the specs to see what we were running. I don't want to go through that right now. I'll have to just send me an email and I can look it up and figure out what it was. Last dumb question. There's no dumb questions. Flat dish home with same compression. A flat top piston is ideal. A flat top piston with a small chamber is better than running a dome piston. Better than running a dome piston and a bigger chamber. Flame travel will be better. Turbo Diesel Dan, my old ZZ4 supposedly came with Lt1 heads. Great little crate engine for 18 years. A ZZ4 doesn't have Lt1 heads because an Lt1 head is a completely different style head that was designed for reverse cooling, and your ZZ4 is not that. It probably has the ZZ4s that we have I think had fast burn heads on them. Should I do a turbo on the 1.6 or a Honda J in my Miata? You don't have to choose between those two. You should do the V6 and do the turbo. Why would a 4.6 run on the passenger side with all 8 coils? If you're looking to try to figure out to diagnose that problem, swap the coil packs and see if it's still doing it, and swap the injector and see if it's doing it. You just have to go through and find out what the problem is. See if you have see if you have spark, see if you have fuel, and trace it back. Find out what the problem is. How much power can I safely get from a 4.8 liter LS? Did you see the first Big Bang? We got over 1200 with a stock bottom end. Richard, have you ever tested a rod mod square port LS intake? I haven't. I've seen them, and I've seen the promises of power that they make it, but I haven't tested one. Okay, it's an Lt1 D-shaped exhaust port. Okay, that makes sense. Yeah, the Miata doesn't have a ton of underhood real estate. I've done some, I did some development stuff for intake manifolds on Miatas, the different variations of the Miatas, and we were able to pick up some decent power. I made adjustable intakes to find out what they wanted, and it worked out pretty well. They never went into production though. No updates on the Nova right now. I haven't done anything with it. I've been down here dyno testing. See, Tim has the answer. It's probably a bad engine temp sensor. Brian, Richard, what size header should I be running on a Ford 408 stroker? It depends on the power output and the RPM. We run, the last one we ran had 1 3/4. I think we could have made more power with an 1 7/8 header. You can even run a step header on it. If it's a 600 horsepower 408, then obviously it needs a different header than if it's a 400 or 500 horsepower 408. What makes better power for the L99, an aftermarket VVT cam, or doing the LS3 conversion with a cam? I would bet that you can make more average power with a VVT cam. The problem is that when you go up in the camshaft, it starts becoming limiting, and then now you can no longer sweep it as much as you were before. VVT cams can make a lot of average power, especially down low. And it's amazing what the right cam can do also at the top, because the LS3 cam is actually going to be a little soft down at the bottom. Richard, do you plan to do any more books? Probably not. Overbuilt automotive. I have a 400M and a set of Lt1 heads. That sounds like a lot of trouble. They will fit if I drill the heads out using all thread grade 8 and bolting them on and a sheet metal manifold. But will the push rods line up and the rockers and the cam and all of that stuff? Will all of that work? And actually, you don't need to put LS heads on a 400M. There's lots of really good 400M heads. There's lots of good Cleveland heads available. Do the race gas additives really work? I haven't tested them personally. We've had people that have tested a lot of the different octane boosters, and they don't really add very much octane. What kind of boost can you safely put to a 6.2 with forged pistons and rod, stock crank, running 11.5 to 1 and pump gas? That's not really a good combination, running pump gas on that, with already it being at 11 to 1. But you could run some boost. You're not going to have very much timing in it, and make sure you have an intercooler. Crowdfunded Gen 6 junkyard big block. Ron, I actually already have one of those in my storage. I have one that I got. It's been there a while now, but I got it from the wrecking yard. It's just been sitting on a stand, so I already have one of those ready to go. Best way to control timing for nitrous on a Pontiac G8. You should be able to do that with the ECU. What's the highest RPM you've ever run a V8? I think probably 82 or 8300 is probably as high as I've ever run. I think we did that with the Ford and we did it with the LS. And we just stopped there. I didn't stop there because something broke. That's just I just got scared and lifted. Yeah, Butler builds the Pontiac 455s and stuff. They've done a lot of them. Those guys, I think, have tested here. Frank, is it okay to email you? Yeah, I provide my email normally to for people. So if you have a question, you send it over. Have you ever tried, Random wants to know, have you ever tried sodium chloride solution in your air-to-water intercooler? I haven't. Randall wants to know, have you ever tested NASCAR heads? We have tested NASCAR heads here because we've tested them on NASCAR motors. We have a couple of them. Westech has a couple of them, old cup motors that are here, and they work pretty well. Chris, what do you think about reusing a 218 224 480 500 lift? That's a pretty low lift cam. 106 LSA, that's pretty tight. 102 intake centerline and Rhodes VMAX lifters. I've never tried VMAX lifters. I think that it'd be interesting to see what your idle quality would be like with that, if the Rhodes lifters would make up for that 106-degree lobe separation angle. I ran a 5 MGE Supra, 1982, 2.8 liter Toyota over 9,000 way back in '95. We've run Honda motors, obviously the B series stuff, up in that RPM range. And I think that the most I've ever seen is the guys at the show shop back when I was doing stuff with Vadim and those guys. They had a Vortex supercharged 3.2 liter Taurus motor that they had done, and that thing was going to 10,000. So it was amazing, and it sounded super cool. I just found your channel. What do you think about LT1 versus 2-valve? What 2-valve are you talking about? A 2-valve Ford? If you're talking about a LT1 versus a 2-valve Ford, that's really not much of a competition. Hey, Richard, can I ask for your help finding information on a Cam Dynamics Stage 1 290H cam for a 351 Cleveland? It was in my dad's shop when he passed, and so I'm sorry to hear about that. And I can't find a card for it. Send me, Mike, send me an email and then remind me. I'd have to see if I can find somebody that has Cam Dynamics information. Richard wants to know, I'm going to do an Ellis swap into an 89 Vet. What's the best Ellis at the yard to get? The best one to get is the biggest one. So if you can find a 6 liter, get that. Most likely you're going to find a 4.8 or a 5.3. I would get the 5.3, and then you can make a lot of power with that 5.3. To give you an idea, that 5.3, a stock one on the engine dyno with the way that we run it, will make 350 or so horsepower and 380 foot-pounds of torque. I've never run a stock 5.7 from the wrecking yard of any year that made that kind of power. You have to go all the way back to a car motor like a real 1970 Lt1 or an L76 365 horse 327, or even the DZ302, although that would be way down in torque. Those things all make about 350 to 360 horsepower. So those like fully built muscle car motors make what a stock 5.3 does that you go get from the wrecking yard. So they're actually a pretty good starting point. And then if you just add a cam and springs to it, you're going to be, you can easily be way over 400 horsepower and closer to, with the right cam, closer towards 450. Lee Stevens says he has a 12,000 RPM 331 cubic inch Chevy and a 69 Nova. That's a lot of RPM. Yeah, Tim, that's the story that he tells you. That's the story that Gail Banks tells you, that he ran the Hemi to 14,600 RPM. He has lots of good stories. Jeremy wants to know, have you ever done any testing on a DZ? If you're talking about a DZ302, yes, lots of testing on it. We did stock. I did a stock one. We built the reproduction of one, and then we did modifications to it. We got it up near 600 horsepower, I think. Certainly in the mid 500s. Those videos are up. We ended up running it with a roller cam and a tunnel ram and AFR heads and all kinds of stuff. But we also ran it in stock trim, and it made about 350 or 355 horsepower. And we compared it to the 327 and the 350, the Lt1 and the L76, the 365 horse 327. And the L84, the fuel injected 375 horse 327. Also, we ran that one. I built a lot of those motors. Those were cool. Mark wants to know if you tested a 377 small block versus the 383. I haven't done that exact test, and I'm okay. I'm going to tell Tim I have 7 minutes. So it's been an hour and 3 minutes, but an hour and 10 minutes I'm going to get off. But Westech has a 372. It's a HP block, and it works really, really well. The bigger bore ultimately, I think, can make more power as long as it doesn't have less displacement than a 383. The thing about it, though, is a 383 has a big enough bore at 4030 to utilize cylinder heads that flow really, really well. So we're talking about heads that flow well over 300 CFM. So at what point you have to get up fairly high in the power output where that starts becoming the restriction. Then if you have a 4125 bore where you have a head that can flow more because it's flowing on that 4125 bore, then you could take advantage of that. Otherwise, I don't think you're going to see much. Like in a 400 or 500 or 550 horsepower range, I don't think you'd see much difference between those two other than the difference in the displacement. An old Crown Vic motor or a 350 in my 01 Stang, what would I be able to mod more? Why wouldn't you get an LS? Yeah, Julius, I agree. And that always comes up when we're talking about stuff. What about a flat plane crank? Because Ford did it and Ferrari does it and various people have done it. But it's the reason that Ford has so many problems is because it's a vibration nightmare. And that's what they fought over and over and over until they finally did it. And you notice they're not doing it anymore. So there's a reason for that. Dave wants to know if I've tested conical valve springs. Yeah, we've run some of the comp stuff, and I've talked to Billy at length about those. Richard Bruce, heads for the LS. What's the best offering at the yard? You're going to want the heads that come with the motor, because you're not going to find a whole bunch. At least I don't find anything that I can interchange. If we find a 4.8 or a 5.3, it's going to have an 862 head or 706 head. And if we find, I never have found a 6-liter. So if we did, it would come with 317 heads. You're not going to find an LS3 there. You're not going to find an LS7 certainly, and probably not any of the truck variants unless you get really lucky. Like I said, I've been going there a lot for a long time, and I've never seen one. And maybe other people in other states or something have. The Big Bang 6.2 L92, 1,550 horsepower. I don't know that block would do that. Maverick, I'm glad you like that cam. I really like it. It works well. I would actually like to work with the guys at Comp to try to make that even a little bit better, and see what we could do. Yeah, Turbo Diesel Dan, Gail is saying the same thing that most engineers say about drivetrain losses not being a set percentage. They're not. It can't be 20%. You can't have a top fuel motor losing 2,000 horsepower through the drivetrain. That's not realistic, because the transmission that you use has a relatively loss. The rear end that you have, the tire size that you have, the axles, all of that stuff. And then friction goes up a slight amount with increased power, but not at the same percentage rate. So I always use the example is if it's a strict percentage, what happens if we take our, let's say that the drivetrain we have is a turbo 400 and a steel drive shaft and a 9-inch and 35-inch tires. And then our loss is obviously 20%. So if we have a 600 horsepower motor, we're losing 120 horsepower. So now let's take that motor out and put a 100 horsepower Honda motor on it. So our powertrain loss is still 20% now of that 100 horsepower. So is our drivetrain now only costing us 20 horsepower? That's not how it works out. The losses will still be the same. As a matter of fact, that Honda motor is going to have a hard time turning that kind of drivetrain, because there's a lot of weight in the tire, and there's a lot of losses through the 9-inch and the transmission and all of that. So if you think about it, whenever I do this stuff, I think about it in terms of extremes. So I got about a minute and a half, and then I got to go. So let's get to one or two more questions. Z German, what's the importance of having a loaded versus non-loaded chassis dyno? That's more so that you can do the tuning in real world if you want to have the option to load it or not load it. A lot of guys do that, because if you do, like I've done lots and lots of stuff, and I had a dyno jet. If you do stuff on the dyno jet, it's not a loaded situation. It's only going to accelerate at the rate of the power output versus whatever the drum roller is. So a lot of guys don't like that. They want a loaded one, and DynoJet eventually fixed that. The Superflow, we can run the chassis dyno over here. We can run loaded. So you can do more tuning with a loaded version than you can with an unloaded version. Jeremy wants to know if I have some type of safety glass. Yes, this is safety glass here. What do you think about the 2JZ motor? I think it's awesome. I have 30 seconds left. You tell when a combination will stop gaining for a bigger rock ratio. Well, we test it and find out. Do I have a hot date? Yes, I have a hot date with an L99, because I have to run this camshaft and find out how much power it made. Okay, last question. Any chance of seeing some old Side valve engines. Probably not. Get to work, Richard. See, I like hearing that. Yeah, gotta go. It's 10. It's 1:10. See, right on time, like always. I never say that I have to go and then stay on longer when I say that. Almost every time. For joining me, guys. It's Saturday night. You guys go have fun. I'm gonna go get on the dyno here and start doing some testing. I got to adjust the valves, put the intake on, manifold on, do some tuning. Wah wah wah. Make some power, and then I have to change the intake manifold. It's never ending. See you guys later, man.